In this video, we're going to talk about how entity models save their input parameter values to the Flames scenario database. As is the case with all the tutorial videos, I'm assuming that you are following the videos in the order that is recommended on the website. So you already know how to run Forge, and you already have your Visual Studio project set up with the tutorial source code loaded. So I'm going to jump right in. You also know something about data sets and and you've worked with Forge and you've saved and loaded data back in and out of the Flames database, loaded scenarios, built scenarios. So we're going to look at the code that is actually present within each entity model to save its data in the Flames database and talk about some of the fundamental principles of that code. Before we get started, I'd like to talk a little bit about some of the principles of storing data on a disk from an application. Pretty much every application that writes data to a disk has to contend with a very sticky problem. And that problem is that file formats and the content of files can change, and often do change, as the application changes. So you see that in Microsoft products when there's different versions of Microsoft Word documents, and Visual Studio has different versions of their project files and solution files, and any application that you think about, if it's been around for a while and they've made changes to it, they've had to change the content of their files, and sometimes that necessitates you having to have different versions of files or have the ability to read and write different versions of files from the application. There are several issues that come up with that, the biggest of which is that when you're doing I/O to a file, you usually have pretty specific code that's expecting certain content to be in the file. And it gets kind of complicated if that content's not going to be there. You have to add a lot of extra logic in your code in order to figure out and adapt to different content. And that code can get rather complicated if you have a complicated file structure and you've got a lot of different data that you're reading and writing to the file. Well, with Flames, that problem is dramatically magnified because Flames doesn't know itself what data is being read and written to data sets. The data that's being read and written to most data sets is coming from the specific classes that have been loaded by Forge and other Flames applications. And each class is reading and writing its own data to that database. So Flames doesn't know what that data is. So we have a problem that, unlike Microsoft has, when Microsoft writes a file, Microsoft knows that it's Microsoft Word, for example, that is the only application that is reading and writing to that file. And the developers of Word know exactly what data is in that file, and they have control over it, and no other data is being written to that file or needs to be read from the file. With Flames, we don't know what data is going to be put in the file. We don't have control over it. Anybody in the world that's using Flames can write any data that they want to the file. So how is it that we could possibly define a version number or a format specifier for that file? It's absolutely impossible. Each class has its own life cycle and its own set of versions. And you've got classes that are all written to the same file from different developers all around the world. So this is a problem that we knew we had to contend with and solve, and we solved it very, very early in the Flames development process. It's really just the first few months we worked real hard on this and tried to come up with this. And the solution that we have is that we store, well, first of all, we have a very high-level API for reading and writing to the Flames database. And you're going to see what that is. So the actual I/O that gets performed on the database is actually not done by the entity model class code. The I/O is actually done by Flames. And so you're going to see that in here. And that gives us the ability to do some really sophisticated things with the data. So I'm going to come back and talk about some of the things that we can do. But first, let's take a look at the code now and see just what kind of code is in a class for doing I/O. So we use a process called registration, which is really the same process that we used in template files. If you've used that, we tell Flames what data, what members of our class we want it to do I/O on. So in the case of the template file, if you might remember, so I'm going to go up here to our EXM sensor, which is the class that we're using for most of these tutorials. You'll notice that in the template file, we specified the names of fields in our structure. We told Flames about that so that it could do the I/O for us automatically with the screen without us having to write any code at all. So we're going to use the same approach for doing database I/O. So we've got these 5 parameter values here that we want to have saved in the data set, in a Flames data set. So what we do during the initialization of the class is we describe for Flames which fields we want to be written to the database. So we define what we call an FDB record, a Flames database record. So here's fentity define FDB record, fentity define FDB record. So we specify the starting address of an instance of our class, which we use where we use the default structure, and you know about that from class initialization. We specify name for the record, and that should always be your class abbreviation, and that name has to match the name that's in the template file. So you might remember from the graphical user interface tutorial that the name of the top level Bob list for the graphical user interface is the class abbreviation, and that name has to match the name of the database record. Then we tell Flames the size of our overall structure, and we tell it how many fields we want in our structure or to be saved to the database. And then we go through here and we reference one of the fields in the structure that we passed in. We reference each of the fields that we want Flames to write to the database. And for each of those fields, we give it a name. And this name has to be unique within a given data set, but these names are isolated within this definition of the record. So these names can be anything you want as long as within the record they're unique. So this is an optional value for format, which we don't usually specify. So this is it. So we've got 5 fields. We've got 5 different records or fields that are defined. This is actually a macro right here that expands to a longer call. And that macro, we've got one for character data, one for floating point data, and one for integer data, and there's a few other macros for more complicated data types. So we define this in the class initialization. We do it one time right up front. In the tutorial where we talk about adding new input parameter to a class, you'll see how we modify this. But this one's all set up for our class. And in most cases, that's all we have to do. We just tell Flames that this is what we want to do I/O, what fields we want written to the database, and it will do the I/O completely automatically for us. Now, just as in the case of the user interface methods, there are also methods that are defined by the classes that are inherited by entity model classes. So FCPP sensor, up in that class hierarchy of abstract classes, there's a couple of methods for database I/O. There's a read method and a write method. So we're going to go look at those read and write methods. And they're always in a file that's called I/O. So we'll go look at that. So here's the implementation of read, and here's the implementation of write. You can see that read has just one subroutine call. You get passed in an FDB object, which is a Flames database object. That's actually an object that is open for a given Flames data set. Flames does all the opening and closing of data sets. You don't have to pay any attention to that. But it tells you which particular data set is open right now, and you have to pass that data set back to this read component function in order for it to get the data out of that same data set. And you pass in an instance of your class, which is the default object for which this method is being invoked. So you just pass in this. And no matter how many fields you have in your data structure that you want written to the database, as long as they are contiguous within that data structure, this one call will read all of them. And similarly, this one call right here will write all of them. Now, when you write this little thing called a proem, which tells Flames in the database, in the data set, that you're getting ready to write one of these records, the record that is defined here, one of these records right here. So the write routine has to make a call to tell the database that I'm getting ready to write one of these records. And if I'm going to write multiple ones, like in a loop, I could put a value other than 1 right here. And then I do a write component, and the same thing. I pass in the object that identifies the data set and an instance of my class. Now, just like with the user interface methods, we have the ability to just delete these methods. I don't have them deleted in this case, just for this tutorial, just to show you what is happening inside of a default read and write methods. But if this is all you are doing in your read and write methods, which in other words, you have just one database record and all the fields, in order for us to have just one record, all the fields have to be contiguous. In fact, I mentioned that again, when you're defining these fields, you're putting one data structure in here and you're referencing that same data structure in every one of these field definition statements. So these all have to be fields that are members of that data structure, contiguous fields in that data structure. If that's the case, then you don't even have to have these IO methods. You can throw this entire file away and you can go to the definition of your class and just delete these lines for read and write. And for most of the Flames classes, the starter components and the tutorial components, they don't have an IO file because the default IO methods are adequate. So for example, here's FEX Radar, and you'll see there is no IO file. And you go to his class definition, he does not have read and write and display and retrieve actually implemented because he doesn't need it. The default behavior for that class is all that's necessary. There are some classes that have more they define multiple records because they can't, all the data that they're writing to the database is not in just one contiguous data structure. So they implement IO methods that that have more complex information in them. And you can go look at that code and search the code and find that code, and you can read in the documentation on how to do more complex IO. There's plenty of examples on how to do that. But in most cases, you don't need to have any IO methods at all. So let's go back and talk some of the philosophy behind this, the theory behind this. If I don't have any IO code at all, none, then how is it that Flames is able to adapt to changes in my data structure? So and we're going to do this in the tutorial where we add another parameter here let me close this off. So we're going to add another parameter to this EXM sensor. You'll see what we do when we add those new parameters in here. We're going to go into the class initialization, and we're going to add a couple of lines here for the new parameters that we add. So we tell Flames that the definition has changed. So how does Flames adapt to that? Well, this is where the real power of this database really shines. And it's one of the reasons why we are not using a third-party database. We're not aware of any database in the world that has this particular feature that requires absolutely no code for the component classes to be able to do the IO, and it provides this format adaptability that I'm about to describe. Before I do that, the first major advantage of this database is the fact that it has so little code or no code. If you look at the IO code in other simulations or other software packages, you'll see the IO code, especially if it's got a lot of data, a lot of different files, a lot of different information, that there's lots and lots and lots of code that is used for IO. The very first version of Flames that we had IO methods, and they had lots of code in there. When as I mentioned, we had to solve this database problem very early on in the development of Flames. We saw that if we were the only ones writing classes for Flames, it wouldn't be such a big deal. But if we're going to release this as a framework and let our customers write their own classes so that all that data is going in the same data set, we have a really, really serious problem on our hands. So we invented this database manager. And when we did that and we swapped over to using that, we threw away well over 10,000 lines of code. And this was early on in Flames when we didn't have that many classes. Thousands and thousands of lines of code. And that's code that we no longer have to write, we no longer have to maintain, we no longer have to change it as we change the database definition of our classes. Flames knows about the definition of these records, and what it does is in the data set, it will store metadata that describes the database record that it wrote to the file. So Flames not only has the data in the file, but it has the structure, the metadata that describes the format of that also stored in the file. So if I happen to come in here as we do another tutorial and I add a couple more fields to this, Flames will automatically look when it gets to this particular code right here, and this IO code, when it does this read call right here, down inside of that read routine, it will look and see that the definition of that database record that's in the code is different from the database record that's in the file. And it will automatically know how to map whatever is in the file to my current record definition. And I've specified default values here for the fields, and I'll do that for the new fields that I add. So those default values will remain intact for the fields that are not, for the member variables that are not stored in the database. So I'll get the default values if they're not in the database. Similarly, if I go in here and I take one of these fields out, so that the file has information in it that is not in my latest definition of the record, Flames knows how to automatically skip that data and just ignore it. It gets a little bit more complicated if your IO routines are not the default ones. If you have records, you have multiple records, but you can also write that code in such a way that the IO code for your current version of your class is forward and backward compatible with any version of your data set automatically without you having to do any coding whatsoever. That is the real power of this database management system. And this illustrates one of the many places where we provide benefit to you as a software developer. As I've mentioned before, or as other people have mentioned in these tutorials, one of our primary objectives in writing Flames and providing a framework for you to develop your own simulations, your own classes that plug into Flames, is to reduce the number of lines of code that you have to write. As you've probably heard before, the cost, the life cycle cost of developing and maintaining software is generally directly proportional to the number of lines of code. It's sometimes called SLOC, the source lines of code. So the SLOC count. So if we can cut down on the number of lines of code that you have to write to implement your code, we are going to cut down on the cost of you developing that code and maintaining that code. So we throw away literally thousands and thousands of lines of code that you have to write to do IO. We throw away thousands and thousands of lines of code that you have to write to put the user interface. You have no user interface software whatsoever. You have just a file that specifies what you want the user interface to look like, and you write no code at all to do the IO for the fields on this screen. And you'll see in an upcoming tutorial when we change the user interface just how simple it is to change a class and change its user interface and change the data that gets written to a file. There's a lot of simulation systems that, in fact, majority of them don't give you the ability to change the user interface. The user interface is fixed by the developers of the simulation. That's not true in Flames. You can put any user interface that you want within the window of the window that's editing your class. And the user interfaces can get really complicated because Joules are really powerful. You do very little coding even in complicated user interfaces. So that's just two places where Flames does a tremendous amount of work for you automatically to save the number of lines of code. But in the case of the database, it's more than just saving the number of lines of code. It provides this functionality to be forward and backward compatible. So you don't have to worry about changing your classes and whether it's going to be compatible with a scenario that you built 2 years ago or 4 years ago. It's going to be able to go back and automatically read that scenario in almost every case. So that's the power of the Flames database. And again, you're going to see that put into action when in a future tutorial we will go in and modify this class to add another input parameter. Thanks for listening, and thanks for choosing Flames.